when things get more complicated, we're taping right now, so we're live. This will be on YouTube. When it gets more complicated, you might find this useful, that I actually tape the lesson that we do, because maybe you cut out, maybe the video feed, you lose it for a little bit, and then you're cutting in and out, and then I'm like a choppy, it's like a choppy thing for you. So we're going to go ahead and tape it and put it on the calendar for backup, for help. If you're absent, same reasoning. So going to be a whole bunch of stuff on the calendar, and I won't be able to put it on probably until after third hour, because this is second. Okay, so I like to teach, using common errors that people do as well. And one of the biggest disasters on this question right here is not reading the directions, add or subtract. And some students see these parentheses and they start going nuts and start doing what actually represents a multiplication. Oh, I get this all the time. Completely wrong what I'm doing right here. So just make sure you focus and understand that the only purpose of these parentheses is to go ahead and distribute the minus sign. Yes, Mickey Mouse start, very simple. Okay, and then the parentheses actually have no meaning anymore. So I just want to really hammer down that point that we do not go ahead and multiply that stuff. The parentheses are just for the subtraction. And then adding like terms, 4y squared. Negative 2y, negative 1y is negative 3y. And then notice when you add like terms, nothing happens to the exponent. They stay the same. We're not multiplying these variables, so that's stays squared, and then this stays to the first power if you want to write it. Sometimes when I'm done adding like terms, I cross them off so I don't have to look at them anymore, but also make sure I didn't lose any other like terms that go with the y squared and the y. Then minus 2. All right, this is called a trinomial. There's also binomials, which are two terms. And then once you're past three terms, you just say a four-term polynomial, five-term polynomial, so on and so on and so forth. And then some other terms like the leading coefficients. The leading coefficient is the coefficient in front of the highest power. So that is 4. Not that 4 is the biggest number. 4 is in front of y squared, which is the highest power there. And the degree of this polynomial. That degree is 2. When you have a binomial, trinomial, it's just the highest power between those. I should cover this real quick. Hey, I'm going to give you this. This is 4x squared y to the third. Now, I want you to understand that this is a monomial, one term. Terms are separated by plus or minus. The leading coefficient, of course, is 4 because there's only one coefficient. But here's the kicker. The degree of this scenario, and I remember messing with your virtual book, and one of the examples from section 2.1 goes through this. The degree of this is actually, since this is a monomial with multiple variables, it is actually the sum of those powers. So just make sure you understand that. That's kind of a complicated one. In a regular one variable polynomial, the power or degree is just the highest degree in all of that. So just be aware of that as we move forward. Okay, and then I snuck out 38 from our homework. I think you have 37 possibly, just so you understand what perimeter is. And perimeter is the walking distance around an object, and in this case, it's a rectangle. And we know rectangles have sides opposite that are equal, so I might mark that like this. And then the other one's 4x plus 6. So what is the perimeter of this rectangle? You could do this in two ways. One is you can take 2 times each side, or you could write 5x plus 2 plus 5x plus 2. And then 2 times 4x plus 6, or write 4x plus 6 plus 4x plus 6. But that is perimeter. Area is length times width for a rectangle. In the future, you'll probably have those kind of questions as a fat or mac you will today. Oh, okay, lost my pen, lost my pen, lost my pen. Fun stuff. There we go. Okay, so 2 times 5 is 10x plus 4, and then 2 times 4x is 8x plus 12. And then you go ahead and add like terms, 18x plus 16. Okay, any questions so far? Mickey Mouse stuff ain't bad at all. All right, nice little warmer upper for getting ready for this class. I love this question, and it is 45 in the book, and I'll zoom in on the picture. And that is, I actually did a lot of work this summer, actually, in the spring when we went to COVID problems. A lot of work in my house, and it's amazing, a mathematical mind, how you're able to do things more efficiently. And I was able to do that, redoing my whole downstairs. And one of the things I had to do was do molding around the bases of my whole downstairs after redoing the floor. So, okay, they algebraize this. They give you a little situation here with this. And I just wanted to cover this because this happens often. They try to trick you. They're missing this side here. So it asks, how much molding in terms of X do I need? But they're little tricksters because I got that here. And I guess we have to ignore that this door is opening here because we don't need molding there, but we're going to pretend it goes all the way through because they didn't really give us a value here of how big that door is. So we're going to leave that alone if anyone was thinking about that. So before I figure out what is the length of the molding or how much molding do I need in terms of X, we got to find what this is. And there's clues to figure out what that is. I have this whole side, which is 3x plus 4, and then I have, let me pick a different color, this whole side, which is x plus 3. And what you must understand, I'm going to do a new algebra here. I'm going to use colors. You must understand that the blue is green minus yellow. Huh? New algebra. And that equals blue. I apologize if you are colorblind. I've had people that were colorblind the last consecutive years. So I do a lot of colors. You're just going to bear with me and so on and so forth. But, that's the case. So what I could do is understand that this is 3x plus 4, that full green side, minus parentheses, this x plus 3. And then I could go ahead and finish that off, distribute the minus sign, and I get 2x. And then 4 minus 3 is 1. So this blue side is 2x plus 1 based off of the dimensions that are given here. Then I can go ahead and answer that question. Write an expression to represent the amount of molding needed. Again, we're going to pretend we need to do this doorway as well, but there's not enough information otherwise to say how much less do I need because of that door. So it just ends up being all these added together plus that found 2x plus 1. So this would be the biggest mistake, people not figuring that out, that I'm missing that little component. Oh, my bad, dog's roof. I forgot another part. This is missing. Yikes. What a maroon. I almost screwed that up. It's going to be the same reasoning, though, for that blue. It's 6x, this whole thing, minus this 2x plus 2. And then that will end up being this part. So I almost screwed that up. So there are 2 missing parts in here. Then that ends up being 4x, distribute the minus sign, minus 2. So 2 missing parts. I'm just making sure you're being careful here. All right, I'm going to run out of room here. So where did I start? I started with 3x plus 4, 2x plus 2, 2x plus 1, 4x minus 2. I need another x plus 3. And I need that 6x on the bottom. Okay, a lot of like terms. Ain't no thing, no. 3x, 5x, 7x, 11x, 12x, 18x. Okay, making sure hopefully I'm doing good math there. And then 4, 5, 6, 7, 6, 5, 6, 7, 8. Hopefully I did all that right as well, plus 8. And then Sam used 80 feet of molding. What is the measurement of each edge of the ceiling? Really what this ends up being is solving an equation. So this represents the full dimensions of all, all the way around all the molding. And he used 80 feet. Hopefully this wrong, plus 8 equals 80. And I hope this works out evenly. Subtract. I never was good at math. How many times does 18 go into 72? Carter, do you know? All right.
4.
4. 4 times 10 is 40. 4 times 8. Look at you. Wow, nice. X equals 4. And now what you do is you plug in 4 in all of these dimensions. 3 times 4 is 12, plus 4 more is 16. 2 times 4 is 8, plus 2 is 10. And then blah, 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 all the way around. Okay, so that's how you'd end up solving that. Does anyone have any questions at this point? I don't want to go too fast, but really wanted to get our formal lesson going here. Going once, going twice, no sale. Okay, now to 2, 2. 2. All right, now we're starting to multiply. Okay, now I mentioned, going to mention some factoring as we go moving on. And actually, factoring is the reverse of multiplying. So everyone knows, I hope, that you go ahead and distribute is the word for this. Boom, boom, boom. And then when you distribute, negative times a negative is a positive. Then that's when you start moving those exponents up. Y squared is y times y, times another y is 3 y's multiplied together, which means it's y to the third. Okay, simple enough. And then this is minus 2y squared, Mickey Mouse, and then plus 7y. So when you multiply, this is the answer. When you factor, this is the question, and then this becomes the answer. Now, I know that's weird that it's a negative y pulled out. We could pull out a positive y, but that's what I want you to think about as we go ahead and multiply in these sections. Multiplying, all fine and good. What the problem is, throughout my history of teaching of 25 years, students really are bad at factoring. And I think they really don't understand that factoring is just a reverse of multiplying. So when we talk about factoring, this will be the question, and this will be a potential answer. Undistribution, the reverse of that. So just keep that in mind as we go. Oh my. Now we got another situation where, can we use the word distribution? Sure. It's a binomial times another binomial. So we could distribute the 2x. I don't know why that pen always goes away there. So I distribute the 2x, but I also like to use this 4-letter F word, FOIL. Okay, first 2 terms, 2x and 4x. Multiply those. Then outer terms. Or all I'm doing is distributing the 2x. Okay, but I like to also use that word FOIL because it's actually a good word. I don't mind it. And then I lost my pen again. Love it, love it, love it. There we go. Then take the 1 and distribute it, or I call those the inner 2 terms, and then I call these the last 2 terms. Or all I'm doing is distributing the 1 as well. So I distribute the 2x, I distribute the 1, and I end up with 2 times 4 is 8, x squared, x times x. 2x times 1 is 2x. 1 times 4x is 4x. And 1 times 1 is 1. All right. And then the middle term does end up adding. So multiply, this is the answer. Believe it or not, when I factor this, and I'm going to show you some tricks on that, that's why I like to use the word FOIL for multiplying, because it's reverse foiling when we factor that and turn that into that question. So I know I'm jumping ahead of myself. I just fear for the factoring coming up, that we become good ones at doing it in this honors class. Okay. Any questions so far? All right, let's keep plugging away so then we can eventually get to that ed puzzle, which, okay, I do have a couple things. A real tough question I have coming up here. There's another way you can actually multiply these as well. I'm going to show with the lines. You take this and distribute. The word FOIL does not work on this because there's going to be 6 multiplications. I have to distribute the 2x and then distribute the negative 3x. And you feel free and go ahead and do that. I'm just going to show you another option that you have with this multiplying. You can turn this in to like a grade school multiplication. How Lexi Samulus multiplies numbers right now without a calculator. Times 2x squared minus 3x. And then doing it like this. This is actually not too bad. And you are actually distributing. And I guess the way Lexi Samulus would do it, you do this term first, which it really doesn't matter. First of all, make it plus a negative 3x. And then what you're going to do, like Lexi does, is go ahead and multiply this, this, and this, like that. Okay, it's like a form of distribution, but writing it like grade school multiplication. So negative 3x times negative 2 is 6x. Negative 3 times negative 3x times negative 4x is negative 12x squared. The only thing you have to do is make sure that you write this like a polynomial, and understand that this is a polynomial with terms. And then negative 3x times negative 3x squared is positive 9x to the third. And then when you do the next line, you can line up like terms right above and below each other. So I don't really care. I'm not going to make you do both ways. I'm going to give you options, and which way you feel most comfortable with is the best. 2x squared times negative 2 is negative 4x squared. And I'm going to write this underneath the x squared column, already aligning like terms. 2x squared times 4x is 8x cubed. All right, and then 2x squared and negative 3x squared is negative 6x to the fourth. All right, then you can go and add these, and now you already have your like terms aligned. So it's a really good way of keeping things in order. But the cubed is all scary looking. 17x cubed, and then negative 6x to the fourth. All good? Any questions? So as we are proceeding on, you could have very easily done that way as well. Make sure you had your 6 multiplications and just organize. All right, I got one of these again. I like this number 40 because we have to figure out some stuff. We got to really break this down, like the net of a rectangular box and its dimensions are shown. Write an expression for the surface area of this box. So how much cardboard do we need? Okay, and you have to do something. You have to make some management decisions. We got to break this down. And this isn't the only way to do this. But I figured I'm going to do this. I'm going to get this yellow area because I can break this down. Then I'm going to get this green area. And then I guess I have this little sliver left over for this blue area. And I'm going to find all 3 of those dimensions, go ahead and find those areas, and then add them up. All right, so we could have done this a couple different ways, but I tried to do the most, efficient where we have the least amount of sections here. But you must understand this is no longer x plus 3. This is x plus 3 plus another x. So our yellow dimensions, length times width, is 2x plus 5 times x plus 3, which is 2x plus 3. And that represents the yellow area. All right. The blue area, we must be careful. And actually, they don't really mark this all the way through, but this is also x. They don't really show that dimension. So the flipped up sides that create the box, those are all x's there as well. So in the green area, we must focus that this is 2x plus 5 from here to here, but then another x and another x. So actually, that is 4x plus 5. And then still x plus 3 for its length or width. I don't care which one you call which. And that represents the green area. Again, 2x plus 5 is only from here to here. We got to get this x added and this x added. So that is why it's 4x. All right. Then the last one, we just have a dimension of x up and down here. And then I lost my pen again. I love that this is happening. And the blue's length is 2x plus 5 still. So it's 2x plus 5 came off the screen times that x. All right. Then what you got to do is I like to use the word FOIL. And hopefully you get good with foiling. You can hold some stuff in your head like that's 4x squared. Hopefully you can hold that this is 6x and 10x, which is 16x. And then 3 times 5 is 15. Again, holding stuff in your head. This is 4x squared. And then this is 20x and 5x. That's 25x. 5 times 5 is 25. Coming off the screen again, 2x squared plus 5x. And then go ahead and add like terms for 8, 9, 10, 10x squared. And I swear I do like doing this, just to make sure I didn't miss any other x squareds. That's 10x squared, and I don't see any others, so I'm good. 16 and 25 is 41, 46, 41x plus 5, 46x. Hopefully my math is solid here. Feel free to stop me if I make any mistakes. 15. Yes, did I do something? What happened?
On the green area, isn't it supposed to be 4x plus 5 times x plus 3?
Oh, I'm a maroon. Unbelievable. Thank you. Who said that?
Yep. Diego.
Diego. Thanks, Chief.
Yep.
All right, so we got to make some adjustments. Nice. Okay, 4x squared. Oh, so that's for 812. Okay, so this is going to change. 12x and 5x is hopefully 17x, right? And then this is 5 times 3, which is 15. That should be the only adjustments I have to make, correct? Yes. All right, good. Right at the spot where I have to change that 46 now. All right, so 16 and 17 is 33. So 38x. Doing a lot of mental math here. Feels good to get my brain activated, but hopefully I'm not making mistakes on the adding. I already made a mistake on the multiplying or writing something down incorrectly. And then 15 plus 15, is that all we have is 30? I lost my pen again. So much fun. Plus 30. Okay, so just a little thing to make sure you're careful on getting those dimensions correctly and finding the missing parts kind of situation. So I do like those, extending the, a little bit more challenging questions, I guess is what I have to say about that. Okay, so I'm going to stop recording.